This is Electric Universe Geology Earth News. We're back at Valles Caldera. I said Valles Caldera the last time, and the S is silent. It's the Spanish pronunciation, as opposed to Mars, which is Valles Marineris, which they pronounce the S. It's very confusing. Anyway, this is the caldera, the alleged volcano. Here's Los Alamos. You can get a really good deal on some nuclear weapons here. Anyway, this is supposedly a volcano. There's not a lot of question about that. I think it's fairly well understood. I see it, on the other hand, as an area that was surrounded by water that had a vortex with a prevailing northwest to southeast wind while there's a vortex going on that created this, in the same way that it creates circular mountains or craters or things that are similar. We're going to see things that are similar to this that weren't completely dry all the way around. So there's some openings where there was water, where there was accumulation was prevented because there was water in some areas, where this is a nice round one. There's a drainage here that drains this whole area, comes down through here. We have pictures from down here looking up at the welded tuff that blew in from the northwest, coincidentally. And there's a drainage over here. I don't think it drains the caldera itself. I think it drains a smaller area. So we're going to see the pictures, see the layers, and then see other similar formations around the world. This is on the northwest side of the caldera. This is a hogback that goes all the way along the western fringe of the volcano. It actually is part of the formation that we looked at recently, where I admit my ignorance. It's similar. It's not as energetic in places. It's a much smoother formation. It's not vertical. The current density wasn't as high. I'll show you what it looks like now. So here's that hogback. There's a road cut right along here. It makes it really nice to see. You have these black layers that are similar to the black layers that we were looking at with the other formation that convinced me that things weren't dunes. I'll bring up some images of that. And you have these areas of rock that are similar to the other hogback that we looked at, and up here you have rock also. This is similar to that other road cut, but not as energetic. All of these trend towards the northwest. It's different, but very similar. Here we have the formation we had looked at earlier, the other hogback that convinced me that things were not dunes. This is the rocky section, similar to the rocky section in that hogback we were just looking at. And here we have some black, either shale or coal, it's hard to tell. And then we have this muddy looking mess over here. It's different than this. If the current density wasn't as high as this, would be my first guess, or the materials could be different. This could have carbonate over here, but to me this is wet, this is semi-molten, with some coal or shale in between, which is the same pattern as that other road cut hogback. And this all surrounds this alleged volcano. And if you think about it, the material shouldn't be deposited this way. It should be coming from the volcano going out. This material is coming towards the caldera, as if it's being pulled in electromagnetically. If it was welded tough from the volcano, it would be going in the other direction. Now we're going to look at some real gnarly welded tough areas that are very impressive. So as I was approaching this with my friends, we were all convinced this was basalt. There's some places where it's fairly columnar, and it's sitting above what looks like slosh. Pretty dramatic slosh. It could be pulled in from the air, wet dirt, or it could be a flood that came in that coated an area that was above the flood. It's hard to say how this got here, but it looks like it's waterborne. With this, which turns out to be welded tuff, which is all over the place with this formation, is welded tuff. And the interesting thing is, when you look at a cinder cone and you see the vents you'd expect to find something similar in an area like this, where there's spectacular amounts of welded tuff that had to be much, much, much hotter than the cinder cone, because the cinder cone turns the dirt right downwind. This stuff had to stay molten for very large distances, coming from vents that no longer are there. So it's a problem for the standard model. For a vortex of molten dust, it just fits in so nicely. This shot gives you an idea for the amount of sloshed, or what looks like waterborne in one way or another material, and then the welded tuff at the very, very top. And again, it looks columnar in places, but it's not basalt. So this is an enigma. So here we are. Here's the volcano. Here's where that road cut is, where you could see the gentleman walking along the side of it. And as you drive east from here, there's a formation over here that just sticks out. There's mountains, but on the very top, close to the very top of the mountain, there's something of a mesa. And it's fairly well known. Georgia O'Keeffe had her ashes scattered there. She spent a lot of time and did a lot of paintings of it. I'm going to really stomp on the pronunciation, but it's Cerro Pedernal, Pedernal. I'm sure it's not even close. But it sticks up. It might not be the tippy-top point, but the only way this could have been deposited that I can see is if there was a filament, like an aurora filament, like the things you see from the northern lights, where there's a distinct filament that has an edge to it that came along, and either the whole area was flooded, which is a possibility with this flood from the equator, and this was all that was sticking up, or the filament was just so narrow it just spackled this area in a welded tuff type of process. I'll show you the image I have of it now. Again, this thing sticks out like a sore thumb from far, far away. It seems obvious the wind was from the left, blowing this way, stacking up the material in a welded tuff type process, layer after layer, backing up into the wind. And this could have been the water line, and it might have grown that way, or this was a really narrow filament only coating this one area that was sticking up, probably above the flood. But it's hard to say for sure. I don't know what the BCD answers would be for this one, but to me it's filamentary. It's similar to the aurora. So let's look at a couple of other real quick formations around the world that are. We don't have to go too far for the first similar formation. Here's Valles Caldera. Here's Grants, Mount Taylor. This to me is the same thing as Valles Caldera. It's just that to the south there was water down here. There was a flood going on. There's a drainage that comes through, a little river now that's not much to it. But at the time this was probably flooded right up to the edge here, which is why there's an edge. And it created something really similar with welded tuff. There's a lot of uranium here. I assume it was either transmutated or attracted during these electromagnetic events, but it's commercial mining of uranium. So this, if it had been dry, in my mind, would have been circular. This is probably on a vortex that created Valles Caldera. It's part of the Four Corners episode, I believe. Let me zoom out real quick and show you what I'm talking about. But here we have our Four Corners, where I think something big happened, and here's a circular area that's similar. Flagstaff, very volcanic. Grants, Los Alamos, this is all volcanic in here. This is unbelievably volcanic, although it's not from volcanoes. It's melted dust that was pulled in. There's a circle of melted dust that surrounds this, that's part of these formations. This is especially interesting. I think all of this area was excavated electrically, creating all the melted dust for this. The wind brought it around and created all of this. This was all part of the end of the process. Now let's go to Australia real quick for the end of this thing. Here we are on the eastern coast of Australia. This was probably underwater, and you probably have a vortex here coming around. Couldn't accumulate where it was wet, but it accumulated here. I'd like to go there. I'd like to see if it's welded tough. If I know there's some folks that live around this area that have communicated with me who asked me about this, which is how I learned about it in the first place. So it'd be nice to have some pictures to get some geologic information about it. This almost looks like the center of the caldera, but it may or may not be. This could have something to do with it, but these are similar looking formations that I think are vortices, and there's a lot of these around the planet, so this is not that unique. Anyway, thanks for your attention. Thank you.